For the unknown F, this is the second unknown. As I explained for the previous unknown, we are going to have only the soluble group plus the sulfide group here. To test for the soluble group, which is sodium, potassium, and ammonium ion, I'm using the original solution. I place about 10 drops of the solution in a test tube. I'm going to clean the nickel wire, the loop, to make sure that there is no residue of ions on it if due to prior use. And then after it's clean, no obvious color of the flame is given off, I'm going to let it cool down slightly and then place it in the solution. Test for color, for the presence of sodium, potassium, based on the color of the flame. You can record your observation. Because it's unknown, I will not tell you that, look, here is this ion or that ion, as I said before, your observation. We are going to look at it straight without the cobalt glass. And we are also going to check the flame through the cobalt glass. With the cobalt glass also, we are going to see if you have any new color or not. Record your observation. You're going to have to do a close-up caption for this one. Okay, we are using unknown and we are checking for presence or absence of the ions that to test for the presence of ammonium ion, presence or absence of ammonium ion, because it's an unknown, I'm going to follow the procedure. Place the 20 drops of sodium hydroxide into an evaporating dish. After I have the sodium hydroxide in the evaporating dish, then I will add the sample. Has to be the original. What I mean by original is that before adding any reagent that will form the precipitation. So this is just the original unknown that is given, and they told me that the unknown label is unknown F. So I take the few drops. I would add a few drops of the sample into the into sodium hydroxide, and I fan the vapor if there is any ammonia or not. Since you cannot detect, the computer doesn't help you detect the odor, I have to give this information. There is no odor of ammonia in this case for this unknown. Okay. For the sulfide group, I'm going to start with 20 drops of the unknown that is given to me. The letter for the unknown is unknown F, and I label this test tube A, so I can keep track of the steps and which solution I'm working with. I add the 20 drops of the sample. I use the marker for labeling because I need to use the centrifuge often, and I do not want the marker or the tape to fall into the centrifuge. Then I'm adding 10 drops of sodium hydroxide to precipitate. The thioacetamide would be another reagent that will precipitate the sulfide group, but it does produce the H2S, which is toxic and volatile. And to avoid any complications and any problems, I separate the sulfide group from the chloride group. And if I only have sulfide group and no chloride group, solubles are all right. But if I don't have any chloride group, I can precipitate that with the sodium hydroxide. So I add the 10 drops of sodium hydroxide. I'm going to add 5 drops of hot water. There are two types of procedure here. One procedure, it says to place the test tube in hot water bath to get it hot. And another procedure is, it says to add the 5 drops. I mean, there's two approach, not to test tube, basically two procedures, two approach. as long as I can warm up and make sure the solution is hot, it will work. We have the precipitation. You can record your observation and you follow the procedure, moving to the next step. In the next step, I need to do the centrifuge, the mixture, to separate the centrifugate. And you will be recording your observation based on the color and what is happening on the following steps. Level of the liquid, you just want to make sure that is the same on both test tubes. And start the centrifuge. Okay, centrifuge is done. I'm going to take the centrifugate and transfer into test tube label B. Now, I'm saving the test tube B for further analysis for next steps to the precipitate, because I need to wash the precipitate. I'm going to add the deionized water, just following the procedure, and you can just watch me and record your observation. I'm adding the water based on the procedure. And this would be the washing of the precipitate. So I want to make sure that I would mix it well. Mix it well with the stirring rod to wash the precipitate with the solutions that I added, and centrifuge again. Okay, when the centrifuge is done, because this was the washing solution, I do not need the washing solution. I'm going to decant into waste container. I do not need this. I place it somewhere that I don't use it again. Eventually, in part C, I need to dissolve this precipitate. So I'm adding nitric acid to it, nitric acid for it to start dissolving. So I kind of give like a head start to it and leave it here for part C. For the part B or test tube B that I have saved from previous steps. So to this solution, I'm adding the hydrogen peroxide, a drop or two of the hydrogen peroxide, to make sure that if I have a chromium 3 is oxidized to chromium 6. The reagent that will show if the chromium ion is present or not is the barium chloride. If barium chloride is added to the solution containing chromium, a yellow thick precipitate, yellow colored thick precipitate should form. And by adding the barium chloride solution, now I also hold the black background. You can check and see that you record your observation. You could see if the precipitate, the yellow color precipitate has formed or not. Record your observation. So we are done with the test tube B, confirmation of chromium. Now we can start working on the precipitate that we had with the previously, precipitation that we had for iron and manganese. The precipitate, it should have been dissolved already. I'm just going to add a couple extra drop of the nitric acid to make sure that everything is dissolved, because we kind of moved fast and it didn't give enough time for it to dissolve. So we are on the next step now, testing for iron and manganese. Okay, the precipitate has dissolved in nitric acid, and I'm going to divide into two aliquots. One is test tube D, and the other one test tube E, based on the procedure. And we are using the test tube D for manganese And for the manganese, I would use the sodium bismutate. After I add the small amount of sodium bismutate, I would hold the test tube for you to look for recording your observation and formation of any color that you need to identify presence of manganese. I'm adding the sodium bismutate, just a small amount of the sodium bismutate for you to see a color change. And I'm going to bring it, hold it close to the camera. And as I'm adding, if you notice any color change, you record the color. Okay. To the next test tube, which is the test tube E, we are adding potassium thiocyanate and testing for presence of iron. And I want you to record your observation. This is the end of the unknown sample for your unknown 1 that included the soluble and chloride, and unknown 2, which is the soluble and the sulfide group. After you watch the video, you record your observation, you also need to submit a rationale and a flow chart. The flow chart is basically should include all the steps. And if you're missing any ion, because not all ions are present in the unknown, your unknown sample has limited number of the ions present and some are absent, your rationale should show which ones are present, which one is absent. And the flow chart, the observation part of the flow chart, it should say which one, what was the observation. So you would kind of defend your case, and based on your observation, you would say that the specific ion was absent. So for your explanation, for example, I mean, of course, you're reading the lab manual for this, says that the unknown contained did not contain chloride group, because when you add HCl, there was no precipitate. That's how you defend that unknown did not contain chloride group. Or if it did contain sulfide group, when you add the sodium hydroxide, it did precipitate. That's like after adding the chloride or HCl, no precipitate, then you add sodium hydroxide, it did precipitate, you do have sulfide groups. And just every step you have to say what is happening and why you think ion present, or why you think that ion is absent. Thank you.